Hello class and welcome to 1.3 Trigonometry of Angles. So today we're going to be incorporating the cast rule and discover that in some cases there are two angles that represent the same value. And that's again discussing or remembering back to our cast rule of when the ratios are positive in which quadrant, as well as the fact that sometimes your reference angle is in quadrant 1 or it can be in the other quadrants depending on what we're looking at. All right, so let's take a look here. Draw the angle 30 degrees in standard position. So again, we start here. We know it's going to be in quadrant 1 because if we got to the marker of quadrant 1, quadrant 2, that's 90 degrees. So that is 30 degrees, ladies and gentlemen. And remember, that's our special trig ratio, okay? So let's fill in the values that we know for that. Okay, so our adjacent side would be root 3, guys. We know already that our opposite side is 1 and our hypotenuse is 2. That's your special 1, 2, root 3 triangle. Okay, now it says to determine sine of 30 degrees. Okay, so sine of 30 degrees. Again, that's your opposite over your hypotenuse. Okay, and in this case, folks, it is 1 over 2. Okay, if you plugged it in your calculator and went sine of 30, that's going to give you, in your calculator, sine of 30 degrees is going to give you 0.5. Okay, is there another angle that will give you the same value as sine of 30 degrees? Well, first of all, let's make sure we recognize our cast rule, C-A-S-T. Okay, and what we know in quadrant 1 is that all of our ratios are positive. And since our answer here for sine of 30 is positive, what other quadrant would the sine also be positive in? It's also going to be positive in the second quadrant. Okay, so what in fact I could do is I could draw another triangle here and go 30 degrees. And I could also say, hey, this is root 3, this is 1, and this is 2. I could draw that, okay? But how do I find this specific angle? So for example, we know this is our terminal arm, but if I take it from the initial arm to here, how do I figure that out? Basically, you take 180 degrees and you subtract 30 degrees from it, which equals 150 degrees. Okay, so if you plug that in your calculator, ladies and gentlemen, and you go sine of 150 degrees, you will in fact get the same answer. So sine of 30 degrees equals the sine of 150 degrees, and using your calculator, they both equal 0.5. And again, you've got the special triangle to prove it there. All right, let's take a look at another example here. Okay, so again, all you have to do is take your original triangle, see if it's positive or negative in that quadrant, and then find its other quadrant that either matches it where it's going to be positive or where it's going to be negative. Okay, second example. Is there another angle with the same value as cos of 45 degrees? If so, how can you find it? So first of all, 45 degrees is in quadrant 1. Okay. And again, that's our special triangle, which is 1, 1, root 2. Okay. So the cos of 45 degrees is again your adjacent side over your hypotenuse side. Okay. And in this case, our adjacent side is 1 over root 2. Okay. Using our cast rule, noticing that it's a positive answer, okay, you will see that where else is cosine positive, and it's and in fact, it's positive as well in the fourth quadrant. So I'm going to draw my second triangle like this, which is 45 degrees, and again, 1, 1. Here's your 90, and here's your 90 if you weren't sure there. So again, we have it in the fourth quadrant. Okay, how do we figure that out? So i.e., how do I figure out from my initial arm this angle? Well, if we completed the whole circle, that would be 360 degrees. And we're going to subtract the 45 degrees. Okay? So what do we end up with? 315 degrees. So again, cos of 45 degrees, if you plug that in your calculator, doesn't say exact value here, so let's just plug it in quickly. Okay, so go cos 45. Okay, it's going to give you 0.707 approximately. But if we try to do the same thing, cos of 315 degrees, plug that in, cos 315, you're going to get the same answer. So in fact, cos of 45 degrees equals the cos of 315 degrees. Remember, your calculator will always give you that reference or initial angle, okay? That's why you can always use the cast rule to find your second angle. Let's take a look at tan of 60 degrees. Just 1 second. Okay, I apologize. Give me a second. Sorry. Sorry, guys. Just give me a second. Sorry, guys. I'm trying to do this on a PD day, and I'm trying to fit it in before I go to my PD day. So back to this lesson quickly, guys. Let's finish this off. So what we're going to do is say, how about tangent of 60? Again, 60 degrees is in quadrant 1, okay? And we remember our cast rule, okay? Tangent is positive in here, okay? And just remember that 60, 30, so here's my root 3, here's my 2, here's my 1, right, guys? Okay, so if tangent 60, okay, equals the opposite over your adjacent, the exact value would be root 3 over 1, which equals root 3. Where else is tangent positive? It's positive in quadrant 3. So basically, I'm going to draw it like this. Here's my 60 degrees. And again, I've got my 1, my root 3, and my 2. So tangent of what angle do we get in order to make that? For example, from my initial arm, how do I get that? So basically, you need to find your reference angle, which means, sorry, your total angle, which is 180, and you have to add the reference angle in, which is 60 degrees. Okay, so adding those together, you should end up with 240 degrees. So again, tangent of 240 equals, again, root 3 over 1, which equals root 3. So tan of 60 degrees equals the tan of 240 degrees. So basically, you're just finding the other value, okay, based on its positioning. Let's just set up a general rule for that. Okay, so our calculators will always give us the angle that is in the first quadrant, or the acute angle. The second angle depends on which ratio it is. So again, you used your cast rule to see if you're adding or subtracting that angle. So for sine, you're going to take 180, subtract theta, which is your angle given, because that's in quadrant 2. For cosine, you're going to use 360, subtract the angle because that's in quadrant 4. And for tangent, you're going to take 180 plus that reference angle, which is Q3. Okay, lastly, let's determine the values for theta between 0 and 360. So in this case, we need to first of all find the angle. So we're going to use our inverse buttons for our trigonometric functions. So to get theta here, you're going to go sine inverse of 0.9659. Okay, plug that in your calculator. You should get that the angle equals 75 degrees. Because it is the sine ratio, and this is in the quadrant 1, what other quadrant does it exist positively in? It exists positively in Q2. So to find your second angle, so second theta, you're going to take 100, so second theta equals 180, subtract your reference angle, of 75, and you're going to get 105 degrees. Okay. Second example, cos theta equals the same 0.9697. Got to get the angle. Got to find the angle. Again, you got to use your inverse button, so it's going to be the cos inverse of this value. Okay. Plug it in your calculator, and we want to round it to the nearest degree, so it should be 14 degrees. Again, cos is also positive in quadrant 4, so to find your second theta, you're going to take 360, subtract your reference angle, and that's going to give you 346 degrees. And lastly, the tangent theta equals 1.4281. Again, that's just a ratio of the two side lengths, which is your opposite and your adjacent. So to get the angle, use the tan inverse of 1.4281. Plug it in your calculator. You should get theta equaling approximately 55 degrees. Okay, where else is tangent positive? In Q3. So that means you take, for the second theta, you're going to take 180 degrees, and you're going to add your 55 degrees. So you're going to end up with 235 degrees. Now I just double check to make sure I've got my degree symbols in here. I think it's pretty good. So ladies and gentlemen, here ends today's lesson. Hopefully you've using the cast rule and deciding when to add or subtract it from 360 or 180 degrees. Here's your homework, page 9 and 10, numbers 1 ABC, 2 ABC, 3 ABCD, 11, 13 CGH, and 14. Have a great day, and again, as always, come and see me if you need some help. See ya!